A ball thrown vertically upward at time t seconds, t equals 0 seconds, has this height. Y of t equals this. First thing, graph y of t. So we graphed it over here with this window. And we must understand that the ball, here's the ground, the ball is thrown straight up and it comes straight down. So it reaches a height and it comes down. This graph here is not a trajectory. It's just a graph of the height of the ball with time. So as the ball goes up and then down, the height goes up and it comes down with time. Okay, so now we're supposed to find the velocity function v of t using the limit definition of the derivative. So we set up the difference quotient and we plug in the t plus h in the function here, and then we subtract off the function at t, simplify it all out, expand out this part for the t plus h squared, keep on simplifying it, simplify it, simplify it, factor out the h, cancel out the h's, to get 1 only if h is not 0. Then we go to the next, continue on. This is what we have. So then the derivative of y with respect to t, which is another way of saying it, or y prime of t, is this limit definition, which we've algebraically shown is equal to this. There's no trouble there. Plug the 0 in for h. It wipes out the 16h, and you just get the derivative function. So y prime of t, the derivative of y with respect to t, which is the instantaneous rate of change of the height with respect to time. Well, that's the velocity of the object. And we found that is equal to 96 minus 32t. And that's in feet per second. So part C deals with what is the instantaneous velocity at time 2 seconds. So we plug the 2 in, plug the 2 in, and it comes out to be 32 feet per second. And then they also said at 4 seconds, the velocity at 4 seconds, plug in the 4, and you get negative 32 feet per second. So it said what's going on with the negative then? So this negative sign right here. Well, as stated, here's the ground. The ball goes up in the air, and then it comes down, straight down. So at 4 seconds, the height, y of t, is changing downward. It's losing height at 4 seconds because the ball's coming back down. That's why it's negative velocity, because it's going downward instead of upward. Whereas at 2 seconds, the ball was still going upward, still gaining height as time changed. So that's what the different signs mean. part E says what happens when the velocity is 0. So set v of t equal to 0. That's this. Set it equal to 0. Solve it out, and you get t equal 3 seconds. So on the picture, what's the significance there? Well, at t equal 3, you're here. And physically what happens there is here's the ground. The ball goes up, reaches 3 seconds, comes to a stop before it can come back down. It's going upward. It has to come to a stop, 0 velocity, before it can turn around and come back down. So it stopped gaining height right here at 3 seconds and then started coming down again. So the velocity was 0. It was shot off at an initial velocity and it hit the ground at a velocity that was not 0, but at t equal 3 seconds. That's where it hit the top it's ever going to be and came down.